guys. So this is the session 2 on important MCQ questions answers on machine learning, where you will get some important MCQ question that will be very much important for examinations like GATE, NET, and other placement interviews and other competitive examination. So this is the session 2. Well, I try to have means discuss those question answer in details also. I'll try to explain them so that you will grasp the concept also. Okay, so let's start. And yeah, this is Dr. Dibya. So now, question number 6 is you need to point out the wrong statement. K-means clustering is a method of vector quantization. Option A. Option B. K-means clustering aims to partition an observation into K clusters. Option C, K nearest neighbor is same as K means, and option D, none of the mentioned. And you know the rules, that is after each question I will pause for 10 seconds within which you guys try to solve this and you will note down the answers, and after the session you will let me know about your score. Okay? Score means the total number of questions that you have correctly answered. So, what will be the answer for this question? Well, your time started. And answer to this question is C. You know, C means K nearest neighbor is same as K means. But K nearest neighbor, that is KNN, is no way related to K means. So, this is the wrong statement. Okay, so K nearest neighbor has nothing to do with K means. Okay, then question number 7. Which of the following clustering algorithms suffer from the problem of convergence at local optima? Option 1. Option means 1. Okay, 1 is K-means clustering algorithm, 2 is agglomerative clustering algorithm, 3 is expectation maximization clustering algorithm, and 4 diverse clustering algorithm. So options is A 1 only, B 2 and 3, C 2 and 4, D 1 and 3, and E 1, 2 and 4, and F all of the above. So you need to find out those algorithms which suffer from the problem of convergence at local optima. Well, time started. And the answer to this question is option D. Okay, and option D says that 1 and 3, that is K-means clustering algorithm and expectation maximization clustering algorithm, they suffer from the problem of convergence at local optima. Because this K-mean algorithm and EM stands for expectation maximization clustering algorithm, has the drawback of converging at local minima. So guys, you tell me, what do you understand by the problem convergence at local minima? Okay, so this is very simple. I have illustrated also previously. So please comment your answer. Now coming to the next question, which of the following algorithm is most sensitive to outliers? I hope I have repeated many times about this, that one particular clustering algorithm is very helpful while we need to detect outliers. So you need to find out that particular algorithm. Option A says K-means clustering algorithm. Option B says K-median clustering algorithm. And option C says K-modes clustering algorithm. And option D says K-medoid clustering algorithm. So which one? Your time started. Yeah, the answer is none other than our option A, because out of all the options, K-means algorithm is most sensitive to outliers as it uses the mean of the cluster data points to find out the cluster center. So as soon as we have some outliers, obviously the detection or find out means the calculation of mean will surely show you that, yeah, obviously we have some outliers that present in our data set. Well, so answer is A, K-means clustering algorithm. Now, Coming to the next question, question number 9. 9 says that how can clustering unsupervised learning be used to improve the accuracy of linear regression model, that is supervised learning? Means how you will use unsupervised technique to improve the accuracy of supervised learning. Means 1 says creating different models for different cluster groups. Second says creating an input future for cluster IDs as an ordinal variable. 3. Creating an input future for cluster centroids as a continuous variable. 4. Creating an input future for cluster size as a continuous variable. And options are option A 1 only, option B 1 and 2, option C 1 and 4, option D 3, and option E 2 and 4, and option F all of the above. So which one? So which one of these four? Okay, 1, 2, 3, 4 will be you, means will be tell you that clustering will help you to improve your supervised learning technique. Come on, try to answer this question. Your time started now. And the answer is option F. And F says what? All of the above. Okay. Creating an input future for cluster IDs as ordinary variable or creating an input future for cluster centroids as a continuous variable might not convey any relevant information to the regression model for multi-dimensional data. But for clustering in a single dimension, all of the given methods are expected to convey meaningful information to the regression model. Say, for example, to cluster people into groups based on their hair length, storing clustering IDs as ordinal variable and cluster centroids as continuous variables will convey meaningful information. Okay, so that's the answer, and this is a very important question. I think that it will be very helpful for you if you note down this one. Okay, now coming to the next question, last question for this session. Which of the following combination is incorrect? Option A, continuous Euclidean distance. Option B, continuous correlation similarity. And option C, binary Manhattan distance. And option D, none of the mentioned. Your time started now. Well, find out the incorrect one out of this A, B, C, D, 4 options. And answer to this question is option D, that is none of the mentioned. Why? Because you should choose a distance or similarity that makes sense for your problem. Okay, so none of them are, you know, incorrect, because continuous Euclidean distance, you are going to use continuous. You may use correlation similarity also, or for binary you may use Manhattan distance also. All these distance metrics you have to use for this type of evaluation. Okay, so that's it for today. You will let me know your score, how much you have scored. Okay, now coming to the today's questions for this lecture. And today's question is, which of the following algorithm